Hello, everyone. Thank you for joining us for this session. It actually is really an interesting session. The session is by Emre Heves, CEO of Quantag, and he's joined us here from, I believe, Istanbul. And he's going to tell us about a very unique application of graphene, which is graphene quantum dots for product authentication. And he will tell us about an actual commercial success story using this graphene quantum dots. So as usual, the stage is yours. I'll make myself disappear and on you go.
Okay, thank you, Kasha, for kind introduction. Hello, everybody. My name is Emre Heves, and I will be presenting today the graphene quantum dots for product authentication applications. And I will give some examples of our first commercial applications in this vertical. So, throughout the conference, I believe there are a lot of talks regarding 2D and 1D carbon materials like graphene. But today I want to shift the focus to carbon-based nano quantum dots. So basically, there are two promising alternatives to carbon nanomaterials from the quantum dot family, such as graphene quantum dot and carbon quantum dots. So their key properties are photoluminescence throughout quantum confinement, and they have a lot of excellent properties, and their key application areas I will be presenting in my presentation. So let's start from quantum dots. Quantum dots actually are fluorescent nanocrystals with unique optical properties. Their size ranges between 2 to 20 nanometers. Mostly they are composed of semiconductors of group 3 to 5 or 2 to 6. And they have crystalline core structures surrounded by organic ligands. And these ligands provide their electronic and chemical passivation of their dangling bonds, and also solubility in polar or nonpolar solvents. So the most important property of quantum dots is quantum confinement, which means their color can be tuned, their emission color can be tuned, controlling their particle size, chemical composition, or surface chemistry. So when you make the dots smaller, it makes blue shifts, as you see in the slide, and you change the band gap, and it translates to different emission colors. You can see commercial applications of quantum dots, especially in the display market. So they are doing quantum dot TVs right now. So it's only commercial application right now on quantum dot side. And let me give you the evolution of quantum dots. So typically, technology started with heavy metal-based quantum dots, cadmium-based, lead-based, and then the requirement of less toxicity drive the technology to heavy metal-free compositions such as indium-based, silver-based, or copper-based quantum dots. And lately, since the people tend to look for more, no toxicity or low toxicity, there are two very, strong alternatives over there. One of them is carbon and graphene-based quantum dots, which will be the topic of our talk today. So quantum dots. So graphene quantum dots, they are nano-sized fluorescent carbon materials, and typically their sizes are below 20 nanometers. So graphene quantum dot composed of one or few layers of graphene and connected to chemical groups on the edges. So their lateral dimension larger than their height. So it's like it's very like small rectangular shape. And carbon quantum dots have spherical structure, and both carbon quantum dots and graphene quantum dots present crystalline structure and quantum confinement. So the dominant photoluminescence mechanism of graphene quantum dots consists of the quantum confinement effect, such as in the other versions of quantum dots. And in addition to that, their surface edge state can be dominant effect in their PL mechanism. And the last one is the synergetic effect of these two factors. Actually, most of the times they have excitation-dependent photoluminescence, and their emissions can be tuned in the visible range. Their photoluminescence bandwidth is broader than some of the semiconductor quantum dots. Their quantum yield is moderate but improving, and their bandgap tuning with size is less